All right, so that was sequence reverser. Next up, signal multiplier. Read values from in.a and in.b, multiply the values, write the product to out. Okay, so I want to multiply the values together, and so wait, so like, okay, 1 times 8 is 8. Okay, got it. At first I thought that TIS 100 was, oh, wait, there's a lot less corruption in this one. At first I thought the TIS 100 was esoteric and strange, but the design makes it so much sense once you get it. It's like it was designed by a different kind of intelligence, completely different from the computers we know, but familiar too, in a way. I don't believe in New Age bunk, but I can't help but feel it's almost as if it came from a different universe. Okay. That's feelings. Poor old uncle was going insane, probably due to this computer. And now we're using it, so that's great. Okay, so read values from in and multiply them together. So how do we, is there a multiply? I don't remember. Is there like a mult? There is no mul. How do you multiply? You multiply by adding something together that number of times, right? So like 1 times 8 is just add 8 together once, and 8 once is 8. Adding 4 0 times is 0. Okay, adding 8 4 times is 32. Okay, so we just 8 8 8 8 8. So we take the first one and we add it to itself. We basically double it that number of times. How do I want to, well, unless there actually is a multiplier and I'm not. Let's take a look at the manual. And can you see, how do I get you to see this? Nope, that's the quack. That's it. Yeah, I'm only seeing add and subtract. So if we want to do we can use a stack for this by adding in the same number that many times. That makes sense, right? We can add in that same number that many times and then just add them out on the other side. That can work, right? So let's, it doesn't really matter which side is multiplying by which, right? So I can either add 1 8 times or 8 once. So I just have to figure out which one I want to be the count, essentially. And then we add in, we use that count to add into the stack X number of times. This one makes most sense because we're on the vertical for that. But like I kind of have to move over anyways. I don't know if it really matters that much. Okay, so let's say I'm probably gonna have to do this over here. Or I could just move this over here. Oh, I could just do that. Hungry Bear Dev, hello. How are you doing today? What's going on? This is a game called TIS 100. It's a game where we program assembly to play it. And there's a little bit of plot. Each one of these puzzles, we see our uncle recently passed away, and he had this weird TIS 100 computer on his work desk, and our aunt asked us to take a look through it and just sort of like finish the work that he had that he never was able to finish on his own. And then we noticed that he put in some kind of messages that maybe he's kind of going insane. Maybe this computer sucked him into it. Who knows? It's getting weird. So that's what this game is all about. So right now we have gotten to the point where we have these stacks that we can use. And so we need to multiply it. So the puzzle is we need to multiply A and B together. But of course, there's no multiply instruction in this assembly that we have. Angry X Speak, hello, how are you doing today? So what we can do is we can throw in this number n times, right? So if we say I want B in here 1 times, and then I wait until the end, then I just pull it out. So I'm good. You're really a programmer. I can't even figure out state management or C, and you're doing this. I mean, it's one of the things where just stretch ourselves. Like, I don't know. This is something that feels fun to me. I don't do assembly during the day job, and I love puzzles and other things that force you to learn. So I tend to like gravitate towards these type of games. I'm not very good at them, but I do enjoy them. But I'm even worse at like other games that require like precision clicking or anything else like that. But yeah, I think it's fun. It's a Zachtronics game. So if you're familiar with other Zachtronics games, like Pharma Company, Pharma something, it's very similar to that. If you've it's not made by the same people who made Factorio, but like it gives off the same type of vibes, but like a lot more compressed in. So like not open worldy. It's more of like you're building out like a factory or something else where it's like that one specific thing that you're focused on for all the puzzles. And besides that, it's like very open to you of how to solve it. And there's probably 100 different ways to solve this, just like programming. Okay, so we have 2 stacks. I need to decide which one to use. I don't know if it matters that much. I want to throw in one n number of times. So if we just take U and we say, okay, I want to move up. So take it from up and just move it down. Let's also take like this up, down. So these 2 will come down to here. Now I want to move up, right. So that way now they're both available at this point in time, right? Now, let's say I want to move B into the stack, which means I want to move B in the stack a number of times. So that means I want to start with move. Oh, but I won't know to end. So we're probably gonna have to do with a, let's do a start label here. I want to move this one into our ACC. So move left to our accumulator here. And then as long as this is greater than 0, I want to move. Oh, I want to move this to the right, but I don't, if I move it, we start getting the next one. So really we're gonna have to make use of our backup, or I'm gonna have to use like some kind of storage somewhere else. Almudena, hello, how are you doing today? Okay, so yeah, we could make use of our backup. So we move left to ACC. I need to check to see if it's 0 or not, right? So we're gonna jump if it's greater than 0. We're gonna jump to store. So we're gonna have a store. So I guess what are all the things that we're doing? We have to I have to get this, and if it's equal to 0, so we need to just pull it in. So maybe we do have a start, but then we also have to check and then move this in. So we have to start is going to be I save you. I get the accumulator, and then I save you. So I have both of you, and then I need to switch back and forth between the accumulator and the backup. So we have start, we have our we want to do our move or store, and then maybe a check. So okay, so start, I want to move left to ACC and then immediately save it. So that way I have it in our backup. If this is greater than 0, so jump, if it's equal to 0, then we want to jump to retrieve. So jump to our end essentially. If, however, if it's not 0, so it's greater than 0, we want to move our thing in backup to here. So we're gonna just move into store here. Okay, so in store, I want to, let's see, jump. Oh, I want to move up to ACC. So now we have B in ACC right now and A in backup. Okay, so in store. Oh, this would probably be a while loop, right? So the while what we have in backup is greater than 0, so we want to swap. Do I want to assume that we're over there in ACC right now? I might want to. So we're going to, if jump equal to 0, then we're going to go to end. Otherwise, we're going to swap to make sure that we have our what was B in ACC. And then I want to move ACC right. And we're going to keep on doing that until we have 0. So then I want to swap again. I don't want to save, and then we want to sub 1. And then I want to jump to store. So that way we're back to here. And if we're equal to 0, we're done. And then we go to end. And end, I want to now start taking this out and adding it together. Which, do I really want to do that here? Do I have a choice? I could do a 0 terminal thing. 0 terminated. Oh, but what if it is supposed to be 0? Ooh, that sucks. Okay, so if we're in end, I no longer care about what we have in ACC. We're good to go there. So I do need to reset. But actually, hold on. If we're equal to 0 in ACC, okay, so we have 0 now. we're 0 in AC. I don't need to set it to 0. So we just now, we need to add right. And once we're finished adding right, so, oh, but I need to count the number of ones that we have, which we have, right? So we're gonna have to do the exact same thing to the left. All right, hold on, we need more room. Okay, so I want to add what we have to the right. But it's gonna be the same, it's gonna be the same thing. We need to if we're equal to 0 now with what we had in A, then we jump to send. It's gonna be tight. If we are good to go, we add. Okay, so then I don't want to add right. We need to swap. Add right. This is not going to work. I don't have enough. I don't have enough room. Okay, so I can't do it all in one node. I can't do everything in one node because I don't have the room for this. I'm so close to it though. So what I need to do is maybe do the storing up here, and then once we're done storing, we need to tell something else time to retrieve it. So let's just say we take you up right, and then we're gonna move up, right, move left, right. So it's gonna be every other one. We're gonna start with B and then A, B, A, B, A. So you're gonna get B first, and then you're gonna get A. It doesn't really matter which one we use as the counter or not. Okay, so let's move. So if we have our start. Now I'm never saving to start, am I? So wait, I might build to, but I need this move left. So I'm not really losing any room with that. I wonder if I don't need the store. Oh no, I need the jump store here. Yeah, okay, so that's kind of sucks. I wonder if I could put the jumps at the bottom. Okay, so if we start, we want our accumulator for counting. So let's move left to ACC. Now I could have this move the first one over to the right and then continuously send the left one until I send it back. I could like send it a 1 back or a 0. 1 meaning I want more, 0 meaning I'm done. Move on to the next one. That could work. We could do something like that. If I do that over here, that might actually work over here too, maybe, because I don't have, it might be easier. Let me think. I want to try that now. Okay, so you move up, down. Now this one, okay, so let's have A come in multiple times because we have this node here that's a little bit easier to deal with this. So I want one 8 times, so we need to start you by, I wonder if I want to reset this. Okay. I want to grab, let's say I grab B, and we're going to store it. So move you up to ACC, so we prepare you for that. I then want to start counting you down while I move you over to this. So then we jump. Okay, so if you're equal to 0, then we start the sum. If you're not equal to 0, we continue on, right? So if, oh no, this is part of start. So they just move up to ACC, and then that, if I have room for more labels, I'll use them to sort of like give myself mental, like describe it, label what I want to do. Okay, so we have start, move up to ACC, and then we're going to actually do our store. So this immediately goes into store. So we just move you up once. In store, if you're equal to 0, we just go straight to sum. If you're not equal to 0, then I want to take what you have and add it over here. So we want to move left to the right. Okay. That's good. And then I want to subtract 1 from our sum. So sub 1. And then that's going to, next time we run store, we're going to check to see if we're equal to that or not. So then we're going to jump to store. The problem here, though, is that you need to keep on sending out this one until I tell you otherwise. So I almost want to say, let's see, where is this? In start, in store. Pepperidge Farm remembers back in the early 2000s when people said if you used labels, you were a bad programmer. I know. And then I think it wasn't very long ago we used a label in Rust, in our Rust code, which actually made things easier. It made things nice. I have it list to like create a short tutorial on like how to use a label for that too in Rust. It is kind of funny how like, don't do this, you're a terrible person if you do that. And then it's like, oh, actually it's really useful, but only in like, just don't do it for everything. Also, I suppose if you try to tell somebody who's doing assembly to not use labels, they would probably just look at you really funly and go like, oh, how do you think you program in assembly? Okay, so when I move left to right, how do I let it know to like switch to the new thing, right? Let's see, so store, okay, so we store, we move up from right, we sub 1, we jump back to store, otherwise we go to sum. Okay, that's great. So in sum, I want to, now we've been moving up to ACC, so I want to reset our ACC, except we're equal to 0. We already know that. So now I want to just add right. constantly. But how do I know which one we have, right? We move up to ACC, and then I also need to save this so we have a backup of it. So that way I can get the count again and then say, okay, are we done adding? So I want to add right. We want to swap. I want to sub 1. And we're going to jump. So if it's jump if equal to 0 to send. Okay, so we're out of room. If we're sending, we're just going to swap. And then move ACC down. Okay. Okay. So let's run through this manually. So move up to down. So we're gonna move up to ACC. So this is gonna be 8. So we move it up into there, and then we save. So we have 8 in ACC and back. And then we're going to check to see, okay, are you equal to 0? You're not equal to 0, you're 8. So move down here. Move left to right. Okay, so you come in here. You are 1. So we move 1 into the stack. And then I want to subtract 1. So now we have 7 in here. And then we jump back to store. So back to here again. Hey, are you equal to 0? No, I have 7. So move left to right, which should be, so here we need to say move up to ACC, move ACC right. Now this is, we need some kind of logic in here to know, because like this move up to ACC, move ACC right, but we need something here where it's like we need to get new, and then we need to like send. So in send, we're just move up ACC, move ACC right. Okay. Let's see, we save. I could, to prevent it from me having to do anything special here, you know what we could do? We move up ACC, move ACC down, move ACC left. So this gets once down here to grab it, and then once over here, so we're gonna move. Oh, I move up right here. I want to move right down. So we start with moving whatever B is down here first. So I want to move up to ACC. And then we want to check to see if you are 0. So I don't really care, do I? I don't think I care at all. We're gonna have move right down, move up, down. Then we're gonna move into our loop essentially, where we're gonna say if we start subtracting, right? And then we start sending out the number of times. which means I need to save. Okay, so move up ACC, save, move up ACC, swap. So now we have A is in backup, B is in ACC. I could probably save a line by doing it the opposite way. Bringing in A first. Let's do that. So we're gonna move up to ACC, save, move up to ACC, and that's it. No swap needed. So now I have B in ACC and A in backup. When I'm looping, I want to if ACC is 0, so if jump equal to 0, we're gonna go back up to start. So we're done. If, however, it's not equal to 0, we're gonna go ahead and sub1 swap to our backup, and we want to send, so move ACC right, and then swap again and jump to loop. I feel like I could do that better too by moving this back over, but I think this is going to work. And of course, that would switch over here. Okay. So now you magically, just as far as you're concerned, I always have the right number of things that I can move, add from the left. Oh, ad break just started. I didn't even notice that it was going. We can move through this, and then we'll see. If I get it within the next couple minutes, I will wait until that's done. Okay, so ACC, save, store. Okay, so move left to right. So we're gonna store this however many times this is. Jump store. Okay, so some add right, swap, sub1. If you're equal to 0, send, swap, move ACC down. Did I do this right? Let's do a check here. So we have 1 and 8 coming in. Okay, so check to see if you're equal to sum. Move left, right. So we're going to move our left. So, okay, we've got our 1 in here. We move up to, saved it. We're going to move up to ACC. So our 8 coming in. If we're equal to 0, start, sub1, swap. So that's the 1. And then move that to the right. That comes in over here, and we're going to move you in. And then swap back over here. We're subbing 1 from here. If we're equal to 0, go back to start. Otherwise, we're going to send this 1 over and over and over again. And then the same thing here. We're going to send from here over. So we should see 1 get stored in many times. Okay, so we're at 0 now. Let's see when we get the next one. Okay, so we're going to start bringing in 4 here. And then meanwhile, you're equal to sum. So we're going to start going into sum here. Now, how many do we have here? Is this supposed to be 8 of them? So 8 of them are in there. So that's gonna sum. Uh-oh. I just immediately sent that down. That's not right. Okay, so with sum, we add right. Oh, if it's equal to 0, send. Otherwise, I need to go back to sub. Uh-oh. I need I forgot to add the sub here. So we're gonna jump some. Okay, so maybe this will work. Let's try it. Uh-oh. Deadlock? Yeah, deadlock. We're at ACC -2. Okay, so when we start, we should double check that we have everything reset. So let's we move up to ACC and we save it. That's fine. When we store it, we check to see, okay, if ACC. How did I get to -2 in there? Let's do less than 0 for that. Okay, so it's trying to do an add right. We have, okay, so we have the 8 that we wanted to create here. Okay, so wait. Add, we swap sub 1. I think I need to swap one more time. Usually divide by 0 is the problem. This time is multiply by 0. Oh, it might be. Uh-oh, I'm adding too many things into the stack. Okay, well that didn't work out very well. So it's my retrieval code had the problem. So when I don't have the swap in here, what happens is this works, we store correctly, I then sum correctly, in backup we have 8. So I am we're adding right, we swap, we sub 1. If you're oh, it's like less than 0. Oh no. If you're equal to 0, send. Otherwise, jump back up to sum. Oh, and then send, we swap, and then ACC down. So wait a second. This worked for 8, right? So 8, 4. But then as soon as we get the 0 and 4 together. Yeah, so you're right. We have a 0 multiplied by 4. You became a -2 because I guess if let's see, for B coming up, we're doing our count. I think I want to do my jumps at the end of each label, don't I? So instead of jump sum at the beginning equal to 0, I say, where exactly is it getting stuck with that? Oh. Well, why is that happening? That's wrong. Okay, hold on now. Okay, so we need to go through until we get the 8 in there. Okay, then we get them back out. Wait a second, that's wrong. Luminum, hello. How are you doing today? You love YouTube videos of mechanical calculators trying to divide by zero. Those are interesting because don't they like try to do work and they either like infinite or they like literally crash. It's like one of those two options. Okay, so what's happening to my stack? Is that it? Look at that. Okay, so it went all the way down to 0. It did not go back down. It did not like remove it. Everything. I was expecting for like the 1 to 8 that it should go to 0, and that's not what happened. That's really weird. That's not great. They can even burn. Oh, that's great. Okay, so we're in storing for the 1 to 8. And now we're in summing. Okay, so we want to sum. So oh, I swapped. Oh, I need to, before we start summing, we need to make sure. Okay, before we sum, we need to save because like we have move up to ACC and then back up so we can swap and then do that. I need multiple swaps that are happening. So I need to swap before we start summing. So it's almost like I want a sum prep. In which we swap. And this will be sum prep. So jump to sum prep, swap, but then you're just going to go back to sum. So this only happens once. Okay, so we successfully got 8 in here. Okay, great. So then you're good. We need to if we sub 1. Okay, so we add right, swap, sub 1. If you're equal to 0, send. Oh, after the 8, you were greater than 0? What was, wait, what was that? Okay, so we're taking this. Why are we 9? Oh no. This logic is wrong, and that should be an 8. Why are we at 9? Oh no. Okay, so we sum prepped, swap. Okay, so our sum is now assuming that we have the wrong thing. So, oh geez. Okay, so when we're storing, we go to, okay, so if we're equal to 0, go to sum prep. Otherwise, keep on moving left to right, and we know that stuff is working. Not sure that they can actually, well, if it's mechanical and it's like moving parts, they can heat up, right? And if it continues to move and never stops, they'll continue heating up. And even things that are not flammable, if you get them hot enough, they will eventually light on fire. Like flammable is just a recommendation. It's just a suggestion that it's not generally going to be easy to light them on fire, but get them hot enough that anything lights on fire. Okay, so move left, right. We sub one. Okay, so that's no. So that part is going correct, right? So like, the storing is going down, and we have our backup, which is 8, right? So then, okay, we're at 0 now. Great. So it's time to switch over to some prep. We swap, so our backup is here. I don't want to add write at this point in time. I wonder if I didn't. No, okay. I need to do my check here to see. Okay, so it's actually no. I don't want to do my check at the end of the loop. I want to do it at the beginning. So if you're equal to 0, then send. Otherwise, swap, add write, swap again. Oh no, hold on, before, can I want to sub again, so I need to, if we're equal to 0, send, so then let's, sub 1, swap, add write. Let's not do that here. Then we'll swap, jump 0. Okay, is that better? I think it's working. I think we got it. It is really fun. Like, this kind of does feel like those mechanical calculators, right? Where we're like seeing it just go through all the different things as it does it. That kind of, it is kind of fun to look at. All right, let's go through fast though.